Hi guys, today I'm going to be talking about indices and how we can work out questions involving indices with the rules. Okay, so indices provide a way of writing numbers in a simpler form. Indices is the plural of index, and then index is referred to as power. Now when we look at the example, we've got 3 raised to the power of 5 and 5 raised to the power of 4. So 3 is the base number and 5 is the index. Now if we look at the second example, 5 raised to the power of 4, 4 is the index and then 5 is the base number. So we're going to go through the rules of indices. There are about 6 rules of indices. The first rule we're going to talk about will be the rule of multiplication. So we've got a raised to the power m multiplied by a raised to the power n. So we keep the base the same and then add the powers. So we add the powers m plus n. Now if m and n are not integers, a must be positive. So we're going to do some examples. We've got the first example, which is 3 raised to the power of 6 multiplied by 3 raised to the power of 4. So in this example, we can see that they've got the same base, so we're keeping the base and then we add in the indices. So 6 plus 4 will give me 3 raised to the power of 10. So we keep the base the same, and then we add their indices. So this will be 6 plus 4, which is 10. So if we have another example, 2 raised to the power of half multiplied by 2 raised to the power of 3 over 2. Next we're going to do, keep the base and then add their indices. So with the knowledge of fractions, I know that you know how to work this. When their denominators are the same, what we do is to add their numerators. So we've got 2 raised to the power of 4 over 2, which is the same as 2 raised to the power of 2. So this is your final answer. Now we're going to look at the last example before we go into the second rule. So we have 2 raised to the power of 4 multiplied by 2 raised to the power of 2. Remember, keep the base, add their powers. So we've got 2 all raised to the power of 4 plus 2, which will leave my answer as 2 raised to the power of 6. Okay, so the next we're going to do will be rule 2, which is division. So we have rule 2, division. So when you're given this a raised to the power of m divided by a raised to the power of n, what we need to do is keep the base like we did for multiplication and subtract their powers. So we've got this example, 3 raised to the power of 5 divided by 3 raised to the power of 2. So I'll keep the base, but I'm going to subtract their powers. So if I subtract their powers, I've got 3 all raised to the power of 3. So let's do one more example. 3 raised to the power of 4 divided by 3 raised to the power of 7. Keep the base, subtract their powers. So 4 subtract 7 is going to give me a negative 3. So my answer would be 3 raised to the power minus 3. So the next we're going to look at would be rule number 3. So rule number 3 says power to a power. So if I have p raised to the power of a or raised to the power of b, this means that p, which is the base, raised to the power of a multiplied by b. So for this rule, we keep the base the same and multiply their powers. So we're going to look at an example to see how this is done. 3 raised to the power of 6 or raised to the power of 2. What this means, following this rule, is 3 raised to the power of 6 times 2, which will give me 3 or raised to the power of 12. So this is my answer. Let's do one more. 5 raised to the power of 2 or raised to the power of 3. That will give me 5, keeping the base and then multiplying their powers, raised to the power of 2 times 3. That will give me 5 all raised to the power of 6. Okay, now we look at rule number 4, power of 0. So it says that anything to the power of 0 is 1. So we're going to look at some examples. We've got a raised to the power of 0 is equal to 1. 3 raised to the power of 0 is equal to 1. So if we've got 3 raised to the power of 4 divided by 3 raised to the power of 4, this means that I'm keeping this, the base, but I'm subtracting their powers. So if I subtract their powers, I'm going to get 3 raised to the power of 0. And 3 raised to the power of 0 is 1. So we look at rule number 5. Negative powers. So we've got a raised to the power minus m is equal to 1 over a raised to the power of m. So therefore, we know that a, all raised to the power of minus m, is the reciprocal of a raised to the power of m. So we're going to look at some examples. If I've got 3 raised to the power minus 1, this means 1 over 3. And if I've got 3 raised to the power minus 2, this means 1 over 3 raised to the power of 2. Now let's do one more example. If I have 3 all raised to the power of 3, that means 1 over 3 all raised to the power of 3. So we have to always bear in mind that the negative powers, this rule 5 is talking about reciprocal of that number. For example, if I want to write down the reciprocal of n, it's going to be 1 over n. Reciprocal of 5 is going to be 1 over 5. Because if I multiply 5 and its reciprocal, I must get 1. So 5 multiplied by its reciprocal gives me 1. Because let's assume if we put in this in fraction, it's going to be 5 over 1 multiplied by 1 over 5. So if we cancel out, or if we multiply out, we'll have 5 over 5. And 5 over 5, which is 5 divided by 5, is 1. Alright, so this rule 6 is the last rule for index laws. Okay, so if I've got a all raised to the power m over n, that means it's going to be square root of a all raised to the power, or it could be cube root of a raised to the power. So the denominator becomes the root and the numerator becomes the power. We're going to do some examples so you can understand it better. So if I've got 4 all raised to the power of half, that means using this square root sign, I'm going to put 4 in here and the denominator becomes the root and 1 becomes the power. So in other words, I'm going to find the square root of 4, which is 2, and then 2 all raised to the power of 1 will give me 2. All right, let me do one more example. 27 all raised to the power of 2 over 3. 27 in here. The denominator becomes the root, so we're finding the cube root of 27. So when we found the cube root of 27, we square that answer. Okay? So we find cube root of 27. Cube root of 27 is 3. You can also use your calculator to find out cube root of 27. Because when you multiply 3 times, that gives you 27. So now that I have found the cube root of 27, I'm now going to square. So if I square that, 3 squared is 3 times 3, which will give me 9. Okay? So for any number, whatever the denominator is will be the root. So if you've got 4 down here and you've got 3 at the top, that means the denominator becomes the root. So you're looking for the square root, cube root, or fourth root. And then the numerator, which is the number at the top, becomes what becomes the power to your answer. So like for this one, we've done it. So we got the cube root and then we squared it to give us 9. All right, I'm going to stop here and hope you enjoyed this lesson and you understand the rules of indices, because with these rules you'll be able to work out questions involving indices and even questions involving standard form. So I'll see you in my next video. If you like this video, click on like and subscribe, and I'll see you in my next video. Bye.